right, good afternoon, everyone. As people are still filing in, thank you for joining us for our program on how electrification benefits the environment. I'm Erin Driscoll. I'm the Adult Services Librarian at the Wilmington Memorial Library. And I want to thank the Flint Memorial Library and Reading Public Library for partnering with us to promote this event. This meeting is set up as a webinar, so we will not see or hear anyone in the audience, but we do encourage you to ask questions in the Q&A feature at the bottom of the screen. If you wiggle your mouse, you'll see the two speech bubbles there with Q&A. You can enter your questions there. And we ask you to participate in the polls throughout the program as well. And now I'm going to turn things over to Joyce Mulvaney at the Reading Municipal Light Department to start us off.
Thank you, Erin, and good afternoon, everyone. Let me just share my screen here. Give me a moment to get situated. Okay, so hopefully you can see my screen. So Erin, thank you again. So my name is Joyce Mulvaney, and I am the Communications Manager here at the Reading Municipal Light Department. And thank you very much for joining us this afternoon for our event, How Electrification Benefits the Environment. Hopefully you're not missing a perfect beach day to be here with us. Okay, so Erin did mention a few of these things, but the session is being recorded, so it will be available for viewing later on, both on RMLD's website and on the library website as well. To enter questions, you want to use the Q&A box on the bottom of your screen. And again, we just want to thank the Wilmington Library, Reading Library, and the Flint Libraries for partnering with us on this event. We're really excited to do it. Okay, so our agenda for this afternoon, I'm going to talk a little bit about RMLD for those who may not be too familiar. What is electrification? So our topic for today. We'll talk about electrification in the transportation and building sectors. And we'll cover the environmental benefits and drivers for both of those sectors. We'll talk about power supply and how that's related. We'll go over RMLD's electrification programs and rebates. We're going to stop after each speaker for Q&A, and we will try to take any remaining at the end if we have time to do so. Okay, so just a little bit about RMLD. I'm assuming most of the folks that are watching today are our customers, but in case there are any who are not or newer customers, RMLD is a not-for-profit, municipally owned electric utility. We serve the towns of Reading, North Reading, Wilmington, and Linfield Center. So it's about a 51 square mile area. We're governed by a 5-member board of commissioners that's elected by the Reading voters. And then we have a 5-member citizens advisory board that's appointed by the communities we serve, and that board makes recommendations to the board of commissioners. Meetings are all open to the public. The dates are posted on our website, rmld.com. Right now, the meetings are being held virtually on Zoom. Okay, so our topic of the day, electrification. What is electrification? It is the shift to powering end-use devices with electricity instead of fossil fuels. And some of the major examples of that include transportation, so electric vehicles, which I'm going to talk more about in the following slides. Buildings, so heat pumps for space heating, cooling, and water heating, which my colleague Sarah is going to talk about. And then we'll touch briefly on industrial manufacturing as well. And so electrification is essential to reducing carbon emissions, and you may be wondering, why is that? So electrification helps the environment because the shift to powering end-use devices with electricity instead of fossil fuels will significantly reduce carbon emissions in some of the highest emitting sectors in the economy. And that's really going to help the Commonwealth and even the nation to achieve its climate goals. Electrification is beneficial even when electricity is generated using some carbon emitting resources. And we will expand on that a little bit more as we go through the presentation. RMLD has committed to supporting electrification activities with non-carbon resources. So what that means is any additional load that we see on our system from electrification activities will be supported with power supply from non-carbon resources. Another important thing to note is that As power supply gets greener and becomes more renewable over time, electrification will become even more beneficial. Okay, so we're going to talk about the transportation sector. Before we start on this slide, we do have a polling question. So I'm going to ask Erin to go ahead and launch the first question, which is, do you currently own an electric vehicle? Let's take a moment. Votes are coming right in. Couple more votes to go. All right, we can probably close out the voting. And I think, Erin, can you show what the results are? Share the results. Okay, so hopefully y'all can see the results are, so far, nobody in attendance owns an electric vehicle. So hopefully you'll learn a little bit more about those today. And we also have a webinar that we did, I believe it was last month. It's on our website. It's Electric Vehicle 101. And we also had a EV owner panel as a part of that, and has some really great information. So if you are interested in electric vehicles, I definitely suggest that you check that out. We're gonna kind of briefly go over some items regarding electric vehicles today, but there's a lot more information there. All right, we'll ask the second polling question before we keep going. Are you considering buying an electric vehicle within the next 2 years? Awesome. I think we're just about there. So you can go ahead and share those results, Erin. So this is great. More than half are interested in buying an electric vehicle within the next 2 years, which is really exciting. All right, thank you, Erin. Okay, so just gonna go over the different types of electric vehicles. All electric is probably the most well-known one, runs solely on electricity. It can be charged from a wall outlet using just a standard wall outlet, and every vehicle comes with a plug. You can also install a level 2 charging station at your home, which gives you a faster charge. There's over 50 models available right now, and they're steadily increasing over time. So there are some really great options, and the range is getting better each year as well. Another type is plug-in hybrid vehicle. So that's a combo electric, and then it also has an internal combustion engine. They usually have a smaller electric range. And basically the way people drive those is they use the electric first, and then the gas engine is a backup for that. So they do charge a little bit slower, but they're great if you maybe you have a little bit of anxiety regarding relying 100% on electric, or perhaps you only drive 10 miles a day, and you probably won't need to use that gas backup too much. So it's a good option for that. And then the final one is hydrogen fuel cell electric. So it's an electric vehicle, but it's fueled on hydrogen. There are not a whole lot of these, and there is not a lot of fueling available, at least here in the United States. It's primarily in California. But I think that this technology is going to become more and more popular as time goes on. So it's just something that we wanted to point out. Okay, so charging. So this is a big concern for most folks who are thinking about buying an electric vehicle, is how do you charge? So there's a few options. At home, obviously, we talked about the level 1, which is a standard wall outlet. A level 2 charging station offers a faster charge. It does need to be installed by a licensed electrician. RMLD does offer rebates on those and that equipment if you're interested in that. You may only, if you say go with a hybrid, you may only need a level 1 because you might be able to plug it in overnight and get a full charge. But those would be for the much smaller batteries. Another place that folks charge is at work. So it's becoming more and more common these days for workplaces to offer charging stations. There's grants available through the state for employers to put those in, and then RMLD does also offer rebates to commercial customers in our service territory who want to install those. And then public charging is the other option. So there are actually several thousand public charging stations in the United States. They're either level 2 or fast charge. So fast charge will give you a full, like an 80% charge in like 20 to 30 minutes. So those are good if you're, say, driving a long distance or something like that, you need to stop along the way. And a good resource to see where public charging is available is plugshare.com. So they have all the stations listed. They tell you how much they cost, whether they're currently being used or if they're available, and what type of plug they have. So it has all that information for you. But the vast majority of people do charge at home. Like 80% of people will charge at home overnight while their car is parked, very similarly to the way you might charge your cell phone. So what are some of the benefits to driving electric? The first one is cost savings, which may come as a surprise for some. But when you consider the total cost of ownership, so if you take into account the rebates you can get to help with the upfront purchase price, the reduced fuel costs, the reduced maintenance cost, it's actually comparable, and you can save money when you look at an electric vehicle compared to a gas vehicle. We put in a link here to plugstar.com, which is a great little tool to compare. You can, pull up an electric vehicle and a gas vehicle and kind of see how they compare. We have a little chart here on this slide, which is just the fuel cost comparison. So as you can see, for the gasoline vehicle, we have a price of $2.74 a gallon, which is actually a little low right now, I think. And it compares to what it would cost to fuel an electric vehicle on RMLD's electric rate. And as you can see, it's a savings. It's a significant savings. It's around $580 a year. So that's just an estimate because every vehicle is different, but that's to give you an idea. Another benefit is performance. And I know that I don't drive an EV myself, but I've talked to EV drivers and they talk a lot about the performance of the vehicle, which surprises some people. But from a standstill, EVs have instant torque. So they can accelerate very quickly from a standstill. So they really do have a nice performance that EV drivers enjoy. And then the final benefit for EVs is really kind of the focus of the presentation, which is the environmental factor. So battery electric vehicles have a zero tailpipe emissions, and PHEVs have reduced tailpipe emissions, even when these vehicles are charged with electricity that's generated from some fossil fuels. Less greenhouse gases are emitted than a conventional gasoline fueled vehicle. So what we did here was we went to Alternative Fuels Data Center, which is another kind of calculator comparison tool that's available. We put in the 2020 Chevy Bolt, which is all electric. And then we put in the 2020 Chevy Malibu, which is a gas powered car. And it actually shows you the annual emissions comparison. So you can see that the electric vehicle is much lower, but it's not zero. And it's not zero because the calculator takes into account the typical fuel mix used to generate electricity in the selected state. So for Massachusetts, we use a fair amount of natural gas, nuclear. We also use a lot of renewables and hydro. So it takes that into account. One thing again to note is that as power supply gets cleaner and more renewables are added and more non-carbon is added, that will go down even more. So the environmental benefits will increase even more as power supply gets cleaner. So what are some of the drivers? What's driving this change? Car manufacturers are doubling the number of new EV models for sale in 2021. Unit sales of EVs are forecasted to exceed 1 million in 2024. And if you look at the chart on the right, they're actually forecasted to exceed 3 million by 2028, which is a very significant increase. And so what's driving that? Economics, which we already went over. We talked about lower total ownership costs, and people are starting to see that. Incentives. There's still a fair amount of incentives available to help with the upfront purchase cost. So there's a federal tax credit of $7,500, and there's also a state rebate of $2,500. You just want to make sure that if you are looking at a specific model, check that those are still available because there are some restrictions but there's still a lot of incentives. Increasing awareness, I mean, increasing advertisements. You're seeing a lot more EVs in the mainstream market. There were Super Bowl commercials. So you're seeing an increased awareness. And then also the technology improving. So battery capacity is getting better with every new model year that comes out. Another big driver is legislation. So there was, I believe it was in March, Massachusetts passed a very comprehensive climate bill. It had many facets to it, but one of them specific to transportation is that it establishes emission reduction targets for the transportation industry and also creates electric vehicle and charging station targets. So the legislation is going to continue to drive adoption forward. So I am going to check in with Sean and see if I have any questions that have come in before we pass it over to Sarah to talk about electrification in buildings. Do we have any questions, Sean?
Sure. Joyce, you had mentioned that there were other incentives for purchasing electric vehicles. Can you recommend any good sources of where that information is, a state site or on RMLD site, or where's a good place to find that information?
Yep, you can check the RMLD site. We try to keep all of that information compiled in our EV page. Another good resource here in Massachusetts is Green Energy Consumers Alliance. They have an EV program that actually offers discounted prices on electric vehicles in the state. And then the state website for their rebate is more-EV. So that's a good place to look as well. And another incentive I neglected to mention is there is actually a federal tax credit for EV charging stations also. I don't know what the exact amount is, but that's something to look into.
Great, thank you. That's it for this segment.
Okay, so I will pass it over to you, Sarah.
Great, thank you very much, Joyce. I'm Sarah Shedson-Harris. I'm an integrated resource specialist here at RMLD. And I'm going to be talking about the electrification of buildings, which is converting space heating, space cooling, and hot water heating to from fossil fuels to electric systems, typically through the adoption of heat pumps. So I'm going to first talk about heat pumps for space heating and space cooling. Before I did that, I wanted to get a sense here of what sort of heating systems you folks use at home. So Erin, I'll ask you to pull up the next question. Yeah, so you can, so the question is, which fuels do you currently use to heat your home? And select any of them that apply. So you may use a few. So I'll give you a minute or a little bit less than a minute to just plunk in your answers there. Okay. So, Erin, maybe we can close it and see the results. Okay. So it looks like most people are using oil. About 50% of people use oil, and about 40% of people use natural gas, followed by 10% of use propane, and the rest use electric. So lots to learn then. We'll talk more about heat pumps and why they're such a good heating system if you are thinking about converting over any of your heating systems at home. Okay, so heat pumps are electric systems to heat and cool the inside of your house. So they're powered completely by electricity, and they don't burn fuel, nor do they produce heat. How they work is by transferring heat from outside the house, so from the air or the ground, and bringing that heat inside the house to warm it up in the winter. And in the summer, they work in the reverse way. They take heat from inside the house and draw it outside to cool down the inside of the house. So what's great is they're one system that provides both heating and cooling. So you don't need an air conditioner and a furnace. You just have one system that keeps your house comfortable throughout the year. And they're extremely efficient. So if you were to switch over to a heat pump from a fossil fuel based system, particularly if you're switching over from propane or oil, you'll see your energy costs go down quite noticeably. So they're really efficient, great way to heat and cool your home. Another added benefit is they control the humidity very well. So instead of pumping in really dry air around the house, which is typical in the winter for forced air furnaces, they can control the humidity. So it's a little bit more comfortable. And then in the summer, they do the same. So we can keep out that really humid heat we're having today with the heat pump. So we can move on to the next slide, Joyce. So there's two types of heat pumps for space heating and space cooling. And one of them is called an air source heat pump. And this is by far the more common form of heat pump in Massachusetts and New England in general. And so, as I mentioned, they transfer heat in and out of the house. So in the winter, they take out the heat from the air. Even on really, really cold days, they can capture that heat in the air and draw it inside the house to warm the air inside. And then in the summer, they work in the exact same way, but in reverse. And you literally just flip a switch and send that heat from inside back outside. So in the summer, they actually work quite similarly to a central air conditioner, and they look similar too. So they have a condenser outside with a fan, and that moves air in and out. So there's a few different configurations you can have with air source heat pumps. You can have a ducted system, which uses ducts around to move the heat around the house, or you can have ductless systems, which are a little bit less obtrusive and work well if you don't already have a duct system or forced air system already in your house. So very versatile. You can actually have both ducted or ductless depending on how your house is configured, which adds to another benefit. It makes it a little bit easier to install. You can also have single zone heat pumps or multi-zone heat pumps. So single zone heat pumps would be used just to heat or cool one section of your house. So say you have a new extension and you just want to cool that new extension, or you just want to heat or cool a great room or something like that. Whereas a multi-zone system can heat and cool the entire house. So you'd have one condenser, two condensers outside, and then various indoor air handlers or ducts throughout the house. Next slide, please, Joyce. So another type of heat pump is a geothermal heat pump. So these work very similar to air source heat pumps, but instead of transferring heat from the air, we're transferring heat from the ground or from a water source. So for instance, under the bottom of a lake. Using a system of pipes underground. So you could have this system of pipes going horizontally from the house, like in this picture here, or you could have a system of pipes going vertically, right straight down into the ground. Both are very efficient and work well, although they do depend on the geology and geothermal activity of your home and the area around your home. But they work well for both forced air duct work or when replacing baseboards or radiator heating. Okay, next slide, please. So next is heat pumps for water heating. So again, this works very similarly to air source heat pumps, but instead of heating the air inside the house, we're heating a hot water tank. So warming up that water for showers and laundry and things like that. And again, they're powered completely by electricity, so they're clean form of hot water heating, and they operate very efficiently. So you'd likely see reduced energy costs there as well. So as Joyce already mentioned, electricity is lower carbon than burning fossil fuels directly. So if you were to use air source heat pumps in your house, your annual emissions would go down quite significantly. You can see in this graph that the emissions from a home heating system that uses a heat pump is about half as much as natural gas and almost a third less of oil when using it for a furnace. So definitely some major emissions reductions by switching over to an air source heat pump. And you continue to see those emissions go down from heat pumps with more renewables added to the grid and cleaner, lower carbon fuels being added on, which we'll continue to see in Massachusetts and in the RMLD territory over the coming decades. So we're seeing a huge growth in air source heat pumps and other forms of heat pumps, but particularly air source heat pumps in Massachusetts, in RMLD territory, and in New England overall. In the next 10 years, we should be expecting to see about 1 million air source heat pumps being installed in houses. which will mean about 23% of all houses in Massachusetts will be heated or cooled with a heat pump, which is really great news. And we hope to see that trend continue going up and consequently emissions from household heating going down. So there's a few different drivers here. The economics is a huge one because air source heat pumps are such an efficient way of heating and cooling one's home. We do typically see reduced energy costs for a house. So this is a big energy money saver over the long term if you were to switch to heat pumps. They're also, performance is also a big driver here. They're highly efficient and they're getting better and better with the New England cold and winter. We're seeing better and better technologies here to make them work as efficiently as possible in New England winters. So this is really good as well. And just greater awareness and willingness to adopt, both from homeowners as well as contractors, driving more of this growth. Like EVs and like what Joyce was talking about, Massachusetts, the state of Massachusetts is also a big driver here. When they passed the climate bill a few months ago, it included some emission reduction targets for the building sector. And it also legislated a new opt-in municipal stretch code. And this allows municipalities to basically require buildings to be more efficient than what the Massachusetts building code currently requires. So we're gonna have more efficient buildings, and this will drive and push for more heat pumps being adopted. So there's two other areas of electrification I want to touch on, yard equipment and industrial manufacturing. So for yard equipment, like lawnmowers, chainsaws, leaf blowers, those have traditionally been powered by propane and other fossil fuels. So they're stinky, they're noisy, they're produce pollution and emissions. So we're seeing more and more electric lawnmowers for sale, and RMLD is encouraging it as well. We offer some rebates for various lawn equipment. So actually, I wanted to hear from you guys as well on whether any of you have electric lawnmowers. So Erin, maybe we can pull up that last poll question. Okay. Hopefully that's enough time. Okay, so about half and half. That's great. If you are considering getting more yard equipment, I would encourage you to check out our website, rmld.com, and see if there's any rebates there that would apply to what you're buying. So lawnmowers, edgers, trimmers, chainsaws, leaf blowers, all that sort of stuff. Another area of electrification is industrial manufacturing. So industry is a big source of emissions and a big source of energy use. And there's a few areas one can target to reduce emissions and improve the environmental impact of this field, this sector. So motors in industry use about 38% of energy globally. So if we can target this area, we can see a lot of emission reductions. So switching over motors to electrically powered motors, and making sure they're really high efficiency. And we'll see some savings there in terms of greenhouse gases. Another area would be heating equipment. So a lot of industrial processes require heating, not for the space, not to warm the area, but for the actual process. And so if these heating systems can be powered by electricity rather than fossil fuels, then we can see some major reductions in emissions there as well. And then lastly would be heat recovery. So a lot of industrial manufacturing releases heat as waste heat, and if that heat can be recovered and used to produce energy or heat the area, the space like the manufacturing floor, for instance, then we can also see better emissions reductions there as well. And so we're seeing growth here and more innovation, and we hope to continue seeing that going forward. Thank you, Joyce. well, actually, Sean, are there any questions from the audience on?
Sure, there's actually one question where you talked about heat pumps and how they can go into one part of the home or the whole home. If they go in the whole home, do customers need to remove their existing heating system? How does that work?
That's a great question. So they can be used to heat and cool the entire home. So you can remove your former furnace, and they can meet all of your heating and cooling needs. But if you did want to keep a fossil fuel-based system, you can do that as well. So they can be combined with existing heating systems, which adds to their versatility. And in fact, if you are keeping a fossil fuel-based system, you could look into having an integrated control system, which is basically like a thermostat that works with the heat pump and the existing heating system to make sure that they're working together and working as efficiently as possible. So yeah, you can use them with another heating system or without, and both work depending on your needs and what you're looking for.
Great, thank you. That's it on for the questions for this segment.
Okay, thank you, Sean. I will pass it over then to Chuck to talk a little bit more about electricity in RMLD's territory.
Well, good afternoon, and again, welcome and thank you for coming. I am the Director of Special Projects here at RMLD within the Integrated Resources Group, and it's amazing how much of the time people will tell me that everything that comes in is in fact a special project. But I'm taking the opportunity today to kind of look at how energy consumption breaks down between residential electric usage and commercial electric usage. By far, in the residential sector, the largest consumption of energy is for heating, ventilating, and air conditioning. And as most of you might suspect, the bulk of that is actually air conditioning load. About 5% of what houses use is lighting. It used to be a little higher than that, but with everybody using either compact fluorescent or now greater usage of LED lighting, the lighting component has gone down rather dramatically. We have water heating, where it is all electric. It adds to about 12% of the residential load. Appliances, 14%. Electronics, your cell phones and iPods, iPads, tablets, and computers total about 6% these days. And 31% is a variety of other things that are used throughout the home. When we get over to the commercial and industrial sector, we actually find that the single largest usage is other. And a lot of that is process energy. You heard Sarah refer to the heat that's produced when electricity is used to melt things. It used to be used to melt iron ore and aluminum. It is used a lot for heating and process energy, laundromats, etc., some of which shows up as water heating and some of which shows up as other. Lighting is a little higher in the commercial and use sector. HVAC is about 25% on an order of magnitude, about the same, which is what you'd expect for building envelope conditioning. Cooking and refrigeration in restaurants and retail stores is about 16%. Computers occupy another 7%. Other office equipment is about 9%. So this is kind of the breakdown about how energy consumption drives our load and where we can target efficiency measures to address those load components. So next slide, please. So as was indicated, we have a climate action bill that was signed in March. The objective of this bill is to reduce carbon emissions to zero by the year 2050. And this is the first time that legislation has applied to public power or municipal light plants here in Massachusetts. And we actually filed an initial draft of the legislation about 2 years ago and have supported it through the process. So we are working to push towards a carbon-free environment, and our electrification programs target moving energy usage out of the transportation sectors and the building envelopes over to us. And as we increase our electrification, the amount of load that we serve, we are going into our power supply portfolio and replacing the carbon fuel resources with non-carbon resources, so that it makes sense to participate in electrification, because as you do so, we are supplying that new load with non-carbon generating alternatives. So we're making it more environmentally beneficial as we go. Next slide, please. So here is a synopsis of what our portfolio looks like. As you can see, we've been ramping up our long-term commitments to renewable and non-carbon resources. You can see that we've added quite a bit to hydro. It's actually growing over the next couple of years, and we have some more contracts and projects in the works. We have other renewables, primarily wind and solar, that we have been growing over time, and we have been growing our nuclear component. So our portfolio has been growing in terms of non-carbon emissions. At the same time, you can see that we're steering away from carbon emitting resources. We do have the option in the early years of converting those carbon emitting resources to non-carbon resources. And we take a great deal of our direction on those activities from the commissioners that govern our system. So we are public power, we are community based, and we are driven by sustainability and stewardship goals from the community. Now, the black line that's going across, you remember I mentioned that we had a commitment to be non-carbon by 2050. This takes a look, at least for the next 8 or 9 years, at where that objective heads. And as you can see, we are well in excess of the resources that we need to be compliant with Roadmap 2050. We continue to accelerate our ability to produce non-carbon resources. Next slide, please. So our initiatives, you can go online and you can read updated information on our programs, including the incentive levels. I strongly encourage people to do that, since the programs are evolving over time as we have new equipment capabilities out there, and we update our program offerings. Currently, we offer $1,000 per ton on installation of new air source heat pump systems, up to $6,000. And existing systems don't require ductwork and some of the other pieces out there. So we offer incentives of $200 per ton for installation and replacement of air source heat pump systems. We also have an innovative component to our air source heat pump program, looking at technical and education support. Customers who are looking to put in a heat pump would make an application for a rebate or incentive to our program. We then hand the customers over to an expert team that reviews what the contractor is proposing to make sure that the equipment is right-sized and will meet the customer's needs and expectations. We also provide to the customers educational materials and information on how heat pumps work and how they work differently than traditional heating systems. And so customers' expectations are appropriately set before the system is turned on. We think that that leads to a lot more satisfaction with what customers experience with their programs. We also offer upgrades of electric panels in conjunction with heat pump programs or on a standalone basis. Customers have found that they're adding incremental load over time, and that the equipment originally built into their residences will no longer suffice for their lifestyles. And so we offer upgrades to a 100 amp panel for $300, upgrades to a 200 amp panel for $500, and upgrades to a 400 amp panel for $750. Customers have a choice with any of these options to put in a standard panel or to put in a smart panel. Believe we've already talked about our cordless electric yard equipment rebates. That has been one of the more successful program launches in terms of participation. It might not seem like much, but every little bit helps. And one of the more interesting facts that we discovered is that the internal combustion engines used for lawnmowers emit higher carbon levels per gallon of gasoline burned than you find in vehicles on the road. So this is actually a more beneficial program than some of the EV activity that we're doing on a pound for pound basis anyway. Next, please. So our initiatives also include EV charging stations. So if you're putting in an EV charging station at home, we will provide you with a $750 rebate. We do require that as part of that, customers sign up for our time of use rate, minimum of 1 year. And the purpose in that is to get people to schedule their charging overnight. Now, one of the things about electric vehicles that's very different about internal combustion engines is that if you have an internal combustion engine, you have to go out foraging for your gasoline. You have to remember where it was $2.79 a gallon yesterday, where it was $2.85, where it's $2.99, and you head out and you have to fill your tank remotely. With an electric vehicle, you charge it at home, and when you head out, the vehicle is fully charged. We are putting some EV charging stations in and around our service territory because people have concerns about how far they'll be able to go on a tank of electricity. And so we're doing some remote charging station work to try and relieve concerns in that area. But for the most part, about 80% of the charging is going to occur at home going forward. You won't need to be going out looking for gasoline for local use of the electric vehicles. We're also looking throughout our service territory at fleet electrification opportunities. Not all of those will be trucks on the road. but whatever we can find, we're working with people who operate fleets to see if we can get those converted. That would include heisters and other equipment that moves product around in warehouses. It would include electric golf carts, probably not a large fleet, but Zambonis. And all of these are opportunities. They're on our shopping list, and we're looking for ways that we can reach out and convert a lot of these with electric that is supported by a carbon-free portfolio. So next, please. So we have reliability as one of our core elements in our mission statement, and we are continuing to keep that in the forefront of our planning. As we add electrification activities and EVs and heat pumps and other process activity into our retail load, that increases the demands on our distribution system and our peak load. So we are trying to be as efficient as we can when we add these. One of the reasons that we're looking at putting electric vehicles off peak and being able to get the maximum utilization out of our distribution grid as we go through this electrification process. So we're constantly doing work there. And in fact, our engineering and operations team has introduced a new element to their planning called hosting. And what they do is they look at where these load increases are coming on. They check the size of the transformers. They check the ability of the feeders and circuits to be able to manage these load increases. Solar has some special considerations that come with it. And all of this is getting factored into their modeling so that they are building a reinforced, reliable system going forward. We monitor everything that we do. We are upgrading our metering system in order to improve the flow of information and make sure that we stay ahead of this process, both with the distribution grid itself and out in the wholesale market for the resources that we need to serve the load, not only efficiently and economically, but with sound stewardship goals in mind. Next, please. So I will ask the same question that everybody else has. Sean, you got any questions for me?
Actually, several of them. Chuck, one question is, you walked through several of these programs, electrical panels, and then Sarah talked about several of these programs. Where can people find out more information about RMLD's programs?
We should have a complete description for each of the programs that we offer on the RMLD website, www.rmld.com. And there should be an opportunity, if your question is not addressed there, to send us a contact, or you can always give us a call and your inquiry will be routed to somebody able to more completely address it and perhaps point you in the right direction for some of the things that you're looking for. We would very much like to be everyone's go-to resource for information on this. So if you have questions, please don't be afraid to ask them.
Great, thank you, Chuck. Another question somewhat regarding programs. You talked a lot about, electrification and with respect to panels. And the question is from customers saying, should we update the electrical panel before doing any future changes from fossil fuel energy, so that is in place, or would this not make sense? Should we wait until after we do the electrification installation?
Well, if you are looking at doing a system upgrade, going from a carbon-based fuel source to an electrification resource, your contractor should tell you whether your panel has sufficient capacity for what you want to do. I wouldn't go too far out ahead and say, well, I'm going to do it this year on the off chance that I'm going to do it and change my heating system in a couple of years. At the time that you change the heating system, you're going to have a qualified crew there, and they will be able to change the panel out for you at that time.
Great, thank you. We have a couple questions about the supply side of things that RMLD has. First one is, in that graph that you showed in the composition of the different fuel types, the question is, with the retirement of nuclear plants, what's the replacement that will come, or what's the source of the replacement that will offset the nuclear section of RMLD's portfolio?
That is an excellent question. I don't have a good answer right now. What I can tell you is nuclear, or at least the plants that we're involved with, have had their licenses extended to 2046 and 2050. So we still have quite a ways to go before those plants are retired. And over a 28-year planning horizon, there are probably going to be some other resources that come along. I don't know what they will be. I suspect that some of them will be fuel cell technology that is hydrogen driven. I suspect that they will have overcome some of the storage issues with batteries, so that the profile that solar produces, the profile that wind produces, the profiles that hydro produce will be smoother and will match more the profile of usage that we have right now. But I don't know what the exact answer is going to be.
Okay, great, thank you. Certainly is challenging as we look into kind of the crystal ball of future resources.
Well, that's why I'm retiring.
So if you could polish up your crystal ball a little more, Chuck. One question we have is where do we see electricity prices going in the next 4 years?
Well, the easiest answer is up. We've just come off a period, not solely due to the pandemic, where energy prices have been going down. This has been since probably about late 2017, early 2018. The cost of energy production has gone down. Capacity costs have gone down, transmission costs have gone up, but we've enjoyed over the last couple of years a period of declining wholesale electric costs. Those are now leveling off, and I expect will be going up over the next couple of years. And I suspect that we're looking at price increases for energy in the 1% to 3% range. A lot of what drives prices after that is going to be a function of what's available for renewable energy and non-carbon energy, and the increased demand for it as all of the utilities in Massachusetts and throughout New England strive to make their portfolios more carbon free or carbon neutral.
Great, thank you. That's it for questions on this side. Joyce,
Okay.
I'll turn it back to you.
Yep. Thank you. Thank you, Chuck. Thank you, Sarah. I don't know, Erin, did you have any kind of closing, anything you wanted to wrap up with before we end today's session?
Certainly. Just to say, thank you for joining us, everyone. I'll send out a event evaluation email, and I will link anything that RMLD would like to share with the participants today in that email. So keep an eye out for that. I'll also link where you can watch the recording of today's event. All right. Thank you all for
Awesome.
joining us.
Thank you so much for your time this afternoon. Take care.
Goodbye.